Welcome to our discussion on renewable energy design and engineering, focusing on BESS sizing and comprehensive techno-economic analysis. It's pretty fascinating stuff, right?
Absolutely. The whole concept of converting boil-off gas to power a gas generator, which then charges a battery system, is really innovative. Can you break down how they sized the BESS here?
Sure. So the report outlines that the genset is rated at 63 kilovolt amperes, but because we're dealing with real power that does the work, it's like not just apparent power. We multiply by a power factor of 0.8. That gives us 50.4 kilowatts of real power. Multiply that by a 24-hour operation,
Yeah.
and you get a daily energy output of 1,209.6 kilowatt hours.
So essentially, the BESS capacity is designed to be around 1,200 kilowatt hours to capture that full energy. Correct?
Exactly. And then there's the charging efficiency, set conservatively at 80% round-trip efficiency. That means out of that daily 1,209.6 kilowatt hours, only around 967.68 kilowatt hours is actually available for discharge each day.
Right? And it seems like they also factor in a high discharge rating, around 300 kilowatts, so that energy can be released quickly during peak tariff hours.
Yes, the idea is to leverage energy arbitrage. The charging is technically free because it's powered by a gas generator using BOG, and then discharge during high tariff periods increases revenue. It's like having a free energy bonus to play with.
That energy arbitrage really seems to drive the entire financial case. I'm curious, what do you think about their LCOS calculations?
The LCOS comes out to about 5 rupees and 95 paise per kilowatt hour, which is competitive compared to peak grid tariffs that hit around 8 rupees and 50 paise.
Yeah.
And they even analyzed sensitivity with government subsidies, showing that a 40% subsidy could bring LCOS down to just 3 rupees and 75 paise per kilowatt hour.
That's impressive. But don't you think relying on a flat 80% efficiency might be a bit on the cautious side, given new battery tech?
It is conservative, true. It's kind of like erring on the side of caution to account for system losses. While modern Li-ion batteries might perform better, using 80% ensures the calculations are robust, especially when explaining the project to stakeholders.
Makes sense. And then there's the discussion around CAPEX, right? Using a proxy price of 20,000 rupees per kilowatt hour, the total investment for the battery comes to about 24 million rupees.
Exactly. Plus, they also detail the annual fixed O&M cost at around 900,000 rupees. This comprehensive model really highlights both the technical intricacies and financial feasibility, something that's crucial when discussing renewable energy pilot projects.
Right? And what about the strategic recommendations? They mentioned pursuing government subsidies like viability gap funding and even exploring additional revenue streams like ancillary services.
Correct. The report emphasizes that tapping into VGF can substantially lower upfront costs, which in turn lowers LCOS even further. And combining energy arbitrage with ancillary grid services, like frequency regulation, can create extra revenue streams, making the project a diversified investment.
I really appreciate how they've integrated both the technical calculations, like the conversion from kilovolt amperes to kilowatts, and also the market and operational strategies. It's a neat blend of engineering and economics.
Absolutely, and let's not forget the detailed analysis on charging and discharging profiles. It's like looking at a well-oiled machine where every parameter from the power factor to the discount rate is optimized to ensure the project's viability over a 15-year lifetime.
Yeah, it sounds like a robust learning toolkit. I also noticed they cover topics on solar PV project management in parallel, adding even more practical insights for industry practitioners.
True. That integration of renewable energy project management training, covering planning, design, and operational aspects, ensures that engineers and consultants get a holistic view of both renewable energy generation and storage.
Yeah, for sure. It's a comprehensive approach that arms professionals with both the technical know-how and the economic strategies needed in today's smart energy landscape.
Exactly. And it really demonstrates how such projects are not just about technical feasibility, but also about strategic, financial, and operational excellence. Quite the deep dive, huh?
Indeed. Thanks for walking me through these nuances. It's been super enlightening. I'm excited to see how these concepts translate into real world renewable energy projects.
Absolutely. The future of renewable energy really relies on innovations like these. And it's projects like this that pave the way for a sustainable, smarter energy grid.
Well said. Looking forward to our next discussion on these cutting edge strategies.